Okay, we're going to start our second notes here on series and sequences. This time we're going to be talking about arithmetic series and sequences. Again, a sequence is just a list of numbers that may or may not follow a pattern. The series is the sum of that particular sequence, and particularly an arithmetic sequence here is one in which the difference is a consecutive constant. So basically we're adding or subtracting the same number. So the first thing we want to do is look at these sequences, and we want to decide if they are arithmetic in nature or not. So when I'm looking at problem number 1, I can see that we're going plus 5, plus 5, plus 5, plus 5. So I definitely know that our common difference, and that's the number that we're either adding and subtracting, we denote it with D, is a positive 5. And number 2 here, I can see I can subtract 3, subtract 3, subtract 3, subtract 3. So here this is also arithmetic. Our common difference, again denoted by D, in this case is a negative 3. You're never really subtracting, you're really adding a negative, just to kind of keep that in the back of your mind. If I give you a pattern, something like this, we need to figure out what A sub 1, A sub 2 is. So in this case, A sub 1, if you plug 1 in for that n, would give you 5. A sub 2, if I plug 2 into there, is going to give us a total of 8. A sub 3 is going to give us a total of 11. Again, I can see I'm adding 3 each time. So our common difference in this case is 3. Same thing, I got to first figure out what my list of numbers are. So A sub 1 is going to get us 2. A sub 2 is going to get us 4. A sub 3 is going to give us 8. Now this is times 2 times 2, and to be arithmetic, you would have to be able to add or subtract the same number. That is not happening here. So this one has no D. There's no common difference there. All right, we do have a formula for arithmetic sequences. It's A sub n, the last term, is equal to A sub 1, the first term, times n minus 1, depending which term we're looking at, times D, that common difference. So let's look at the way we can work some of these problems. For number 5 here, what we want to do is find the nth term of an arithmetic sequence if the initial term is 5 and the common difference is 8. So A sub n is going to be the first term, so they're telling us here that A sub 1 is 5, plus n minus 1 times negative 1 over 8. We can go ahead and distribute. I'm personally okay, you'll need to ask your teacher, but like sometimes depending on the answers, I'm okay with this form as is. That's n minus 1 over there. Or we can distribute and kind of get it a little bit cleaner. That's going to get us minus 1 over 8n plus 1 over 8. So A sub n winds up being 41 over 8 minus 1 over 8n. Number 6 is asking us to find the 26th term of this arithmetic sequence. What I got to do is get us a formula for that at first. So we're looking for A sub 26. We got to look at some things. You need to know A sub 1, which we do in this case, which is 17. We also need to know our common difference. And in this case, our common difference is negative 6. So I know that A sub n is equal to 17 plus n minus 1 times negative 6. We are looking for the 26th term, so our n is going to be 26. Figuring all that out, we wind up with A sub 26 is equal to negative 133. All right, for problem number 7, what we are looking at is to find the common difference and then write the nth term of the sequence as a function. I know a couple of things here. We're looking at it more of a recursive formula happening here. If we were to let k equal 1, in this case that's going to get us to the second term, so I know A sub 1 is 15. If I let k equal 1, then A sub 2 is going to get us, let's see here, the term before plus 6. So in that case, it's going to be 15 plus 6, getting us a total of 21. If we let k equal 2, we're looking at a sub 3. It's a term before plus 6, so we're looking at 21 plus 6, giving us a total of 27. I can see here we're adding 6 each time, so our common difference is 6. In order to write a function as a sequence of n, or an explicit function here, we're looking at a sub n is equal to the first term, which we know to be 15, plus n minus 1 times 6. This is one form that is acceptable. You can continue on to distribute. And our final answer here would be a sub n is equal to, 9 plus 6n. For me, I find both forms okay. I would go ahead and ask your particular pre-cal teacher which form they want to see that in. Number 8, they're asking us now to find the first term and the common difference given two particular terms in the sequence. Because we're adding or subtracting the same number, this is linear in nature. So in order to find that common difference, we could find it just like we do with slope. So I'm going to say 94 minus 85 is equal to the third term minus the sixth term. It's going to get you 9 over negative 3. So negative 3 is equal to our d. That is our common difference. I know in our formula we have a sub n is equal to a sub 1. We still don't know that a sub 1 at this point, plus n minus 1 times now that common difference of negative 3. You can pick either of these two pieces of information to plug in for a sub n. So I'm going to use this piece here. I'm going to use 94 is equal to the first term. That's what we're looking for. I do know the n is 3 in this case, times minus 3. And we wind up with 94 is equal to a sub 1 minus 6. And I finally figure out that my first term is 100. So we found the two things that we wanted, our a sub 1 and our common difference as well. We could then go ahead. We want to write this just as a formula here. We could be a sub n then is equal to 100 plus n minus 1 times minus 3. If you go ahead and distribute, we get, let's see, minus 3n plus 3, so a sub n is equal to 103 minus 3n. If I want to write this recursively, I need to be given first that first term of 100, and then it's going to be a sub n is equal to the term before minus 3, which is our common difference. Let's go ahead. Actually, problem number 2 works exactly the same way. Why don't you go ahead, try that on your own. If you're having any issues with that, you can certainly go ahead and ask your pre-calculus teacher there. I don't want the video to get too long. Find the 3 arithmetic means, the middle terms between negative 6 and 27. So basically, term 1 is negative 6. We have 3 terms in between, and the 5th term here is 27. So we want to just kind of figure out what that means. I know that a sub 1 is equal to 6. I also know that a sub 5 is equal to 27. I can go ahead and figure out what that common difference is. Remember, with arithmetic, it's linear, so it works like slope. 27 minus negative 6, that should have been a negative there, all over 5 minus 1. That's going to get us 33 over 4 for our common difference. So I know now that a sub n is equal to negative 6 plus n minus 1 times 33 over 4. So now if I want to find a sub 2, it's going to be negative 6 plus 2 minus 1 times 33 over 4. That is going to get me a total of 2.25. So a sub 2 is 2.25. If I want to find a sub 3, it's going to be 3 minus 1 times 33 over 4. That gets us a total of 10.5, so that is our a sub 3. And then a sub 4 over here is going to be negative 6 plus 4 minus 1 times 33 over 4, giving us a total of 18.75, and that would be the last of them. Okay, we want to also look at the sum of an arithmetic sequence. So we want to start adding them up. Finite means that it comes to an end. We can't have an infinite sum because we would keep adding and adding and adding. It wouldn't make any sense. So we do need some kind of finite sum. The two formulas we're going to use here is if we don't have the first and last term. This one's going to help us to get that. This is a formula we can use if we do know the first and last term. We denote the sum by S sub n. So over here I'm looking for the sum of 40 of this particular sequence. You can see it's n over 2, so in this case it's going to be 40 over 2. And here I can see that the common difference here is a positive 4, so we're adding 4 each time. So that is going to be, let's see here. You could do this one of two ways. We can use this formula, so it's going to be 2 times negative 6 plus 40 minus 1 all over that common difference of 4. When we do that, we get 2880. The other thing you can do, if you wanted to, is to write the formula out. A to the n equals a sub 1 plus n minus 1 times that common difference of 4. I do know our a sub 1 is negative 6. If I'm looking for a sub 40, we'd have negative 6 plus 40 minus 1 times 4. And that would get us negative 6 plus 39 times 4. And then 39 times 4, I'm just kind of minus 6 plus 156, so that would get us a total of 150. Then we could go ahead and use this formula, which would be, let's see, 40 over 2 times the first term plus the last term, and that would get us, let's see here, 144 times 20, and that also gets us to 880. Either way works fine. It's just going to depend on which way you prefer. All right, let's look at problem number 2. I want to find the sum here. The first thing I kind of need to figure out is how many terms do I have. I do know that the last term is equal to 41. I do know that the first term is 2. And I can also see here that we have a common difference of 3. So I can figure out what this n is for 41. Distributing, let's see, we're going to get 3n minus 3, so 41 is equal to minus 1 plus 3n. We get 42 is equal to 3n, so now I know that my n value is 14. Looking here, I know the first term and the last term, so it definitely makes more sense to use this formula over here. The sum of the 14 terms is going to be 14 over 2, now that we know there is a total of 14 terms, times 2 plus 41, giving us a total of 301. All right, so here for number 12, again, we need to figure out how many terms we have at first. I know that a sub n, I don't know what the nth term is here, but I know it is equal to 32. I know our first term is 5.4. I could also see here that our common difference is 1.9. We're adding 1.9 each time. 32 equals 3.5 plus 1.9n. We figure out n to be 15. Once we know that, again, it makes more sense to use this formula because we do know the first term and the last term. So the sum of the first 15 terms is going to be 15 over 2 times 5 plus 4 plus 32, and that's going to give us a total for the sum of 15 to be 280.5. Looking at number 13, we are looking at the summation of n equals 1 to 40 of 60 minus 3n's. What we need to get is our first term and then also our last term. So using our summation here, I know a sub 1 is going to be 60 minus 3 times 1. So that's going to be a total of 57. A sub 40 is going to be 60 minus 3 times 40, and that is a total of negative 60. Using our sum formula, I know there's a total of 40 terms, so the sum of the first 40 terms is going to be 40 over 2, the first term of 57 plus the last term of negative 60. And when we add all that up, we get the sum of the first 40 terms to be also negative 60. If you look at number 14, you can see that we're starting at a number other than 1. So really our n in this case is going to be 50, since you are summing a total of 50 terms. So I need to know how many terms we are subbing. I know the first term is going to be a sub 51. So it's going to be 7 times 51, and that's going to be a total of 357. A sub 100, it's going to be 7 times 100, which is a total of 700. So I want to know the sum of the first 50 terms of this particular sequence. It's going to be 50 over 2, 357 plus 700. And when we figure all that out, it turns out to be 26,425. We should be able to work through these problems as far as applications and word problems go. It tells us a theater has a total of 30 rows seats. There are 28 seats in the first row, 32 in the second, and 36. So our sequence is looking as 28, 32, 36. From this, I can demise a couple of things. I know my a sub 1 is 28. I could also see that our common difference is 4. I also know our n is 30 because there's a total of 30 rows, the first row through the 30th row. We want to know how many seats are in the theater altogether, so that would be summing up everything. From this here, we can just figure out a couple of things. I'm going to go ahead and use that first formula. So S of 30 is equal to 30 over 2. That's going to be 2 times 28, our a sub 1, plus 30 minus 1, 30 being our n, times our common difference of 4. And that's going to yield us 2,580 seats. And our last problem for this particular set of notes here, we got a ceramic floor is designed in the shape of a trapezoid, 20 feet wide at the base and 10 feet wide at the top. The tiles, 12 by 12 inches, are to be placed so that each successive row contains one less tile than the one before. So from this, we can figure out a couple of things. We know our a sub 1 is starting at 20. We know that our a sub 11 is equal to 10. We're only going to be able to get the 11 in there. We need to go that extra one space. We also know here that we have our first and our last term, which is great. There's a total of 11 terms total. So what we're looking for is the sum of the first 11 terms to be 11 over 2 times the first term of 20 plus the last term of 10, and that gets us to be 165 total tiles. Okay, with that, that's the end of this lesson, and our next one will be on geometric sequences.